Steps of the hypothesis testing process. Step 1. State the hypothesis. Your hypotheses are the first thing you need to lay out, otherwise there is nothing to test. You have to state the null hypothesis, which is what we test, and the alternative hypothesis, which is what we expect. This should be stated mathematically as they were presented above, and also in words explaining in normal English and what each one means in terms of research questions. Step 2. Find the critical values. We formally lay out the criteria we will use to test our hypothesis. There are two pieces of information that inform our critical values, or the alpha, which determines how much of the area under the curve composes a rejection region, and directionality of the test, para ma-determine nato kung asa ang region. Step 3. Step 3. Compute the test statistics. Once we have our hypotheses and the standard we use to test them, we can collect the data and calculate our test statistics in this case. Step 4. Make the decision. Once we have our obtained test statistic, we can compare it to our critical value and decide whether we should reject or fail to reject the null hypothesis. When we do this, we must interpret the decision in relation to our research question, stating what we concluded and what we base our conclusions on, and the specific statistic we obtained. Example: movie popcorn says that a movie theater owner likes to keep a very close eye on how much popcorn costs each bag sold, so he knows the average bag has 8 cups of popcorn and that this varies a little bit, about a half cup. This that is the known population means, which is 8.00, and known population standard deviation is 0.50. The owner wants to make sure that the newest employee is filling bags correctly, so over the course of weeks, he randomly assesses 25 bags filled by the employee to test for the difference. N equals to 25, or ang meaning sa N is the total numbers of samples. So he doesn't want bags overfilled or underfilled, so he looks for difference in both directions. This scenario has all the information we need to begin our hypothesis testing procedure. Step 1. State the hypothesis. Our manager is looking for a difference in the mean weight of popcorn bags compared to the population mean of 8. So, ang null hypothesis is there is no difference in the weight of popcorn bags from this employee. In mathematically, masulat siya as H sub 0 equals the population means of 8.00. Ang alternative hypothesis is there is a difference in the weight of popcorn bags from this employee. Mathematically, kay ano siya, H sub A is not equal to 0, ay, the population mean is not equal to 8.00. Step 2. Find the critical values. Our critical values are based on the two things, the directionality of the test and the level of significance. We decided in step 1 that a two-tailed test is the appropriate directionality. We were given no information about the level of significance, so we assumed that the level of significance is 0.05. It what we will use. As stated earlier in the chapter, the critical values of a two-tailed z-test is level of significance is equal to 0.05, or the critical value is equal to 1.96. This will be the the criteria we use to test our hypothesis. Mao ni siya naa diri sa bell curve na nakaano diri ang duha ka critical values na 1.96 testing positive side and the negative side. Ang mauntog two-tailed siya. Step 3. Calculate the test statistics. Now we come to our formal calculations. Let's say that the manager collects data and finds that the average weight of this employee's popcorn bags is the mean of equal to 7.75 cups. We can now plug this value along with the values presented in the original problem into our equations for z. So ang equation nato diri is 7.75 minus 8.00 kung siya ang mean unig equals sa negative 0.25. Dari na po sa baba na side ang kaning 0.50 which is the level of significance is divided by 25. The numbers of samples is equals to 0.10. So, ang negative 0.25 divided by 0.10 is equals to negative 2.50. So, our test statistics is the z-score na negative 2.50 which we can draw into our rejection region distribution. So, mao na ni siya diri sa bell curve na gi-draw na to na ang negative 2.50 naa siya diri. Step 4. Make the decision. We can see that our obtained z-statistics fall in the rejection region. We can also directly compare it to our critical value. In terms of absolute value, the negative 2.50 is greater than negative 1.96. So we reject the null hypothesis. We can now write our conclusion na reject null hypothesis based on the sample of 25 bags. We can conclude that the average popcorn bag from this employee is smaller, which have the means of 7.75 cups than the average weight of popcorn bags at this movie theater, which is the z equal to 0 is equal to negative 2.50. So the probability is less than 0.05. Effect size. When we reject the null hypothesis, we are stating that the difference we found was statistically significant, but we have mentioned several times that this tells us nothing about practical significance. To get an idea of the actual size of what we found, we can compute a new statistic called an effect size. So, ano siya ang equation na nasa baba na D, which is the coins D, kunya ang duha ka mean na niya equals sa levels of significance. This is very similar to our formula for Z, but we no longer take into account the sample size since overly large samples can make it too easy to reject the null. Cohen's d is interpreted in units of standard deviation just like Z. For example, ang kaning diri ay the mean na 7.75 minus sa 8.00 is equals sa 0.25. Unya, ano nimo siya sa 0.50 which is ang answer niya is 0.50. Mao na siya ang kalayo sa duha ka mean. I mean, ang difference sa duha ka means. So hence D is interpreted as a small, moderate, or large. Specifically, D is equals to 0.20 is small and coins D na 0.50 is moderate and the D na ang coins D na equals sa 0.80 is large. Other considerations in hypothesis testing. First is errors in hypothesis testing. A type 1 error, false positive, occurs if an investigator rejects a null hypothesis that is actually true in the population. A type 2 error, false negative, occurs if the investigator fails to reject a null hypothesis that is actually false in the population. So, dali naman kayo sa sabton no ang type 1 error o type 2 error. And next is the misconceptions in hypothesis testing. Misconception kay para sa aning the probability value is the probability that the null hypothesis is false. Ang proper interpretation, the probability value is the probability of the result as extreme or more extreme given that the null hypothesis is true. It is the probability of the data given the null hypothesis.